Energy. So energy is a very important part of chemical and physical changes. It's really the driving force behind why these things happen in the first place. So we need to talk about it a little bit. So energy is defined as the capacity to do work. And what's work? Work is defined as the action of a force through a distance. So in science, the term work is used differently than we use it in everyday life. Well, I'm going to work. That's doing something that maybe you don't like in exchange for money, right? Here, this guy's doing work. He is pushing a box across the floor. He may or may not be getting paid for that. He may or may not enjoy doing that. But he's pushing it across the floor. And so scientifically, this is work because he's applying a force to the box and moving it through an area, through a distance. If he just pushes on the box and doesn't move it at all, that does not fit the qualification of work because there was no through a distance. So energy is the capacity to do work. There are different types of energy. The two broad categories are kinetic energy and potential energy. Kinetic energy is associated with motion. Potential energy is associated either with the position of the object or its composition. So here we see a 10 kilogram weight just barely sitting on top of this building. That's an unstable position, right? Because if that gets disturbed, what's going to happen? The law of gravity is going to happen, and it's going to fall and crash to the sidewalk. High potential energy is unstable. So when I lifted that marker up and then dropped it, it was unstable here because when I let go of it, it fell. Something happened. As this weight falls, as it gets closer and closer to the ground, its potential energy decreases because the closer you are to the ground, the less potential energy you have. But it's falling. Is it slower or faster as it goes down? It goes faster and faster. The potential energy is being turned into kinetic energy. So as it falls, the potential energy turns into kinetic energy, and then it hits the sidewalk with a crash. Yes?
Why in the definition is it not saying something relative to the Earth?
That's a good question. Why is it the definition of potential energy not saying associated with position relative to the Earth? Because gravity is not the only thing that can cause potential energy. So if you have a spring, and you compress the spring, and you have something on the spring that's light, right? If you release the spring, it will expand. And so that is a form of potential energy also. So there are different things. This relative to the surface of the Earth is the easiest thing for us to visualize. But yeah, that's why. So when it crashes here, what happened to all that kinetic energy? We've lost the potential energy, so it's now on the ground. As it was falling, it turned into kinetic energy, and now what, nothing? What happens when an object crashes into another object is that heat is generated. All of that kinetic energy that this had as it was moving is transferred into thermal energy of the weight and the thing it ran into. Thermal energy is a form of kinetic energy. It's associated with the temperature of an object. It's the motion of the individual atoms or molecules. So it's not a motion that they're actually moving through space, like a baseball flying through the air has kinetic energy, but they're moving in place. So right now you guys have pretty low thermal energy. Everybody's pretty still. But imagine if we turned on some music and we all danced in our chairs. Our butts stayed on the chair, but the rest of us was just going crazy. That would be high kinetic energy, but you're not moving around, you're stuck in one place. We call that thermal energy. The more the particles in a substance are vibrating and oscillating and moving in place, the warmer the substance is. Okay? So the The kinetic energy of the thing falling when it hits the pavement causes all those particles in the solids to move and vibrate and oscillate. They get all excited, and the temperature goes up. Depending on how big of a crash it was, you may or may not be able to detect the temperature change just with your hand. When you drop a marker, you're not going to be able to tell that there was an increase in temperature. But if you have something really big crashing, you can actually tell that it got hot. So the law of conservation of energy, similar to the law of conservation of mass, energy is neither created nor destroyed. So energy can change from one form to another. We saw going from potential to kinetic energy. It can flow from one object to another object, but the total quantity of energy is constant. So you can't make energy, but you can't destroy it either. So chemical energy, or chemical potential energy, this is where the composition of the substance comes into play. We said potential energy was based on position or composition. So chemical potential energy arises from the electrostatic forces between the charged particles that make up atoms and molecules. And we'll learn a lot more about that later. So energy is always conserved in physical changes and in chemical changes. You can't create or destroy it. If you have something where it appears that energy is being lost, you probably just need to look harder. You're probably overlooking something. In most energy transitions, if you're going from kinetic to potential or vice versa, or transferring energy from one object to another, there's often some heat that's lost. Thermal energy is also one of the forms that it transfers into. That didn't go very well. Let's think about a car. So we have molecules in the gasoline. Gasoline has high chemical potential energy. Gasoline is flammable and burns because of how the charged particles within it are put together. So you give it a spark and it will burn. So we can use that energy in the engine of the car in a controlled manner to cause the pistons to go up and down, and the gear shaft and everything makes the car go forward. So we're taking the chemical potential energy from the gasoline and transforming it into kinetic energy of the car moving forward. What happens to the engine in your car as you drive it? It gets hot, right? If you've been driving your car for a couple miles, you don't want to just open the hood and stick your hand in there. It's hot. You'll burn yourself. Why is it getting hot?
Because that's the point of it.
Well, that's the point of it. That's a good answer.
That's how it creates its energy.
The heat is a byproduct of how it creates its energy. So we use, what happens is the energy is released and we're not able to trap all of it. And the part that gets away from us is the heat. It's energy, but in that situation it's not useful energy. The molecules coming out the exhaust pipe, the products of the combustion, these molecules now are much more stable. They have lower chemical potential energy than the gasoline molecules. Exhaust is not flammable. It doesn't burn. It just is stable. It's just going to blow around in the air.